what we mean by scientific attitude. Like we all should have scientific attitude, especially students who want to make their career in science. Scientific attitude means your mind should be open and flexible. If you have today discovered something and gave a theory which has been accepted, but in case in future some other observations come, you should be ready to say that these were the mistakes in my theory, this is the revised theory. As I gave you certain examples, like for light, nature of light, that light was considered to be corpuscular, but then it was converted to wave theory, and now we are telling it is dual nature of light. So nature of light has changed with time based upon the observations. Now Newton developed physics, his three laws of motion and universal law of gravitation, which will be studying in 11th semester 1, could explain everything. But it was observed that very electrons, protons are very small bodies. When they are moving at a speed comparable to speed of light, then Newton's laws are no longer applicable. So for that, quantum mechanics has been, theory of quantum mechanics have come up. So see, Newton's theory also has been changed to quantum mechanics. But we are using quantum mechanics only when bodies are moving at speed comparable to speed of light. Initially, very long time back, people were thinking Earth is flat, but then later on they accepted that Earth is spherical. Now even persons have seen, they have taken photographs that Earth is spherical, so they have agreed. Initially we had geocentric theory, Earth is at the center, but now we are having heliocentric theory. We are telling Sun is at the center and planets are rotating around the Earth, including around the Sun, including Earth. Is it all right? So we should have scientific attitude in case new observations, new experiments, results cannot be explained by the known theory, then we should revise that theory happily. Now in physics there are two important principles. One is called zonification, other is called reduction. Now what do we mean by zonification? As the word zonification means unity. Means we should try to make very few concepts and laws and explain variety of things on those laws and concepts. Like Newton's law of gravitation, which we will be studying. It is explaining why apple is falling down, why moon is rotating around the earth, why planets are rotating around the sun. All those various other things also can be explained by Newton's law of gravitation. So one law is used for many places. In 12th standard, we will be studying about electromagnetism. They will be studying about Maxwell's 4 equations. Now this Maxwell 4 equation explain all electric and magnetic phenomena. So only these 4 equations is explaining a very wide variety of observations that we make connected with electricity and magnetism. Then there is another thrust, that is reduction. Reduction means in case you have to solve a very complex problem, then you break it into small parts, each units you can say, and try to solve each part independently. And so that the output of one part will go to the input of the next part. So in this manner we can solve the problem. and also sometimes we neglect contribution by small parts, some parts which are very small, like many times we neglect friction. We say friction is neglected because the contribution by friction by the other forces that are applied on the body are very small in magnitude compared to that. Is it all right? So this important two concepts you should learn. Now let us discuss scope of physics. Now scope of physics is divided into two domains, macro MACRO and micro MICRO. As you know the meaning, macroscopic means phenomena of large bodies which we are seeing in the laboratory, terrestrial, astronomical and all those things, large bodies. And for this, whatever Newton had discovered the physics that is called now classical physics, so that explains all microscopic phenomena. Now these various microscopic phenomena are divided into four major sub branches: mechanics, which Newton has discovered; electrodynamics, as I told you, Maxwell summarized the knowledge of electrodynamics in four equations; optics means light, why does the rainbow get formed, why refraction take place, why reflection take place; then thermodynamics. Thermodynamics means when liquid or gases are heated, they do some work. If they are doing the work or we do work on them, then what parameters will change, how much they will change. So that is about thermodynamics. So this also will be learning in our second semester. Then micro means small. So small means all studies, phenomena related to atoms, nucleus are studied in microscopic, and for this we are using quantum theory, as I told you. Now recently a third domain called mesoscopic has emerged. MESO, mesoscopic. Mesoscopic means we are dealing with atoms which are very few in numbers, 10, 20, 30 or 100, 200, very small, but they are not micro and neither they are single. So this is the scope of physics. Other way of looking at scope of physics is by the range of the physical quantities that we are measuring. Length we are measuring from 10 raised to minus 14 meter. Now 10 raised to minus 14 meter has come. It is the order of size of nucleus, 10 raised to minus 15 or so. And to 10 raised to 26, the size of galaxies, bigger galaxies. Then time, from 10 raised to minus 22 seconds, time taken by light to travel to pass one nucleus. And up to 10 raised to 18 seconds, life of sun. Now this you can, for remembering, see, learn length 10 raised to minus 14 to 10 raised to 26. Then for time you subtract it. So minus 14 will become minus 22 and 26 plus 20 will become 18. Then mass 10 raised to minus 30 to 10 raised to 55 kg. 10 raised to minus 30 you can say mass of an electron, 10 raised to 55 is mass of the heaviest galaxy, universe. Okay? Then this physics is connected with technology. Whenever new theory is developed, then technical people try to use that theory in making products which would be quite helpful to the for the welfare of the human beings. And reverse has also been seen. Sometimes they make a product, then scientists think that what is the theory behind it, how this product works, how I can improve that product. So let us try to see examples of both. First, let us see the examples of technology leading to development of science. You might have studied in the school exam that James Watt, he was boiling water the lid was jumping up and down. He wondered why this lid is jumping. Because steam is there, so steam is pushing it out and pushing it out. So steam has got power. So he applied this principle and he made steam engine. And this steam engine resulted in a industrial revolution. So whole world changed due to this. So scientists also thought that what is the theory behind it? These steam engines they saw, they are very inefficient. They require large amount of energy and then they give out they do small amount of work. So they understood the theory and then they changed the cycles of operation and made them more efficient. So this branch in which we are studying about this, that how to get more work done from the by giving from the heated products, from heated gases, is called thermodynamics. Then second, now let us see the problem. We are finding that our fossil fuels are getting exhausted and they are also causing pollution. So this was the problem. So scientists thought over it and they have developed many, and still that process is going on in finding clean sources of energy, alternative clean sources of energy. Now we'll go to other type things. Physics generating the technology. Here you'll get many examples. The laws of electricity and magnetism gave rise to wireless communication technology. Otherwise our mobile phones would not have been there. Silicon chip gave rise to computers. Now you know, after invention of computer, how did the world change? Total internal reflection gave rise to optical fibers. This will be studying in our 12th standard. Reflection of ultrasonic waves. Ultrasonic waves, when they strike, they come back. So we know their speed is same as electromagnetic waves. So we developed sonar by which we can know the depth of seas and identify any bodies in the sea. So these are just a very, very small number of examples of how the physics has gave rise to new technology which has been used for welfare of the people. Now in physics there will be three words will be coming. So I thought let me try to explain their meaning. One is hypothesis. Hypothesis means supposition, assumption. It is not been proved. I am assuming this is supposition, but I have verified by various sets of experiments and I am sure that things are happening due to this. So that is called hypothesis. So various natural observations can be explained by this hypothesis. If there is any natural observation which cannot be explained, then this hypothesis will have to be revised or changed. Now axioms, these were studied in the 9th standard, means self-evident truth. Means we need not prove, we need not do the experiment, they are self-evident. Like if I say two parallel lines never intersect. It's self-evident, so it is an axiom. Postulates means rules. Like when hypothesis is made, they give some postulates that this theory can be applied when these conditions are fulfilled, or these rules have to be obeyed. Now, knowing all these things, we can come to the conclusion. See how exciting the physics is. Why I say why exciting? Because just by studying few universal laws and principles, there are very large number of their applications and I can also apply them and make certain new product. Second, the persons who have a flair for experiments, they find it challenging, that the experiments are challenging to verify or falsify some theory. Some new theory has come, whether it is correct or it requires revision or it is wrong, so they try to, so that poses a challenge to them that which experiment they should do. Then, once the theories are there, how to use that theory for making the good technological products, so that is also a challenge. Then this physics has not only helped physicists in their domain but also in other sciences. Like take example of biology, they have made microscope, they have made electron microscope, so they were able to see very germs, pathogens, and after studying them they derive their conclusions that how to ensure that they don't cause problem, or how to make a medicine that will affect that will not permit them to grow. Then also in biology, the radioisotopes are used to know the suppression of blood, to know where there is a clot, or there is a radiation therapy for treatment of cancer. So various physics techniques are used in biology. In chemistry, we have learned that we should structure of atom only once physicists discovered the structure of atom, and so they could make a proper periodic table and understand various bonds that these atoms will make, why hydrogen reacts with chlorine, why lithium reacts with chlorine, but lithium will not react with magnesium. Helium, why does helium does not react? All those things can be explained because today structure of an atom is properly known, which has been developed by physicists. Okay. Now, in case this modern science, particularly physics, is properly used, we can make good amount of power, and that power can be used for irrigation, for pumping water in irrigation. Then power can be used for various means in agriculture, industry, everywhere. So we can eradicate poverty and hunger. Also, so once these things are eradicated, means prosperity will come. But in case we use this technology in a wrong manner, Earth can also be destroyed fully. Like in case of making nuclear bomb or hydrogen bomb, Earth will not be fit for billions of years. So this I had explained to in previous slide also. This is sort of a repetition. Okay. Chemistry, biology, astronomy. In astronomy, we have developed astronomical telescopes. Because of these astronomical telescopes, it has given an aid in studying motion of planets and other heavenly bodies. In geology, means rocks. When was that rock formed? What is the structure of that rock? That rock is made of what? So we carry out crystal structure of rock using diffraction techniques, and the radiations that they emit, so that by measuring those radiations from which element it is coming, we can find the age of rocks. Now, physics is a quantitative science. As I told you, that in physics, unless you form an equation, quantify the various terms, that how they are related, the knowledge is incomplete. So for that we require mathematics. So mathematics is a major tool in physics. That is why while developing physics, Newton also developed calculus, which is a part of mathematics. Okay. So in case you have understood this chapter so far, then in the next chapter I will explain you two important topics are left. 4 types of forces and about physical laws, how they are affected. So those I will cover in the next lecture. In case you have understood today's session, you can subscribe and press the bell icon so that you will get the notification when I am posting the next videos. Thank you.